Hi students, let's look at another example, still on relative velocity of inclined vectors. The velocity of a ship A relative to ship B is 10 meters per second in the direction north 45 degrees east. If the velocity of B is 20 meters per second in the direction north 60 degrees west, find the actual velocity of A in magnitude and direction. This is an interesting question. So this time you are given the relative velocity. You are given one of the velocities and you have to find the other velocity. That is how this question looks like. So what do we do? Let's try and draw and express each of them first. We are given velocity of shape A relative to B. So what are we given? Let's draw it. This vector is what? So solution. Velocity of A relative to B. How do we write it? Velocity of A relative to B has been given. The magnitude is what? 10. And what is the direction? North 45 degrees west. So how do we do it? Let me draw it quickly. So we have this north east, sorry. So this is what we have been given. We have been given VAB as 10 meters per second. This is north, this is east. That's not it. It says north 45 degrees. So it means that when you find VAB in magnitude and direction, how is it going to be? The magnitude is 10 meters per second, and the direction from the north in clockwise direction to VAB is what? It's 45. So 045 degrees, or you can just write 45. Let's look at the other one. If the velocity of B is 20 meters per second, we are given velocity of B. Okay, and the direction is north 60 degrees west. Let's draw that. This is north, this is west, right? So north 60 degrees towards the west. This is velocity of B. Velocity of B, and it has been given to be what? The magnitude. The magnitude has been given to be 20 meters per second. Yeah, north 60 degrees west. So let's see. So what will be the direction? We are looking for the whole of this. From the north in clockwise direction to this. This angle is what we are looking for. And what angle is that? We know that from here up to here, from here to here, to this place, from the north to this place is 270. So what is this small angle? This small angle is 30. So 270 plus 30 gives us what? You get 300, right? Is that correct? You get 300. So that is that. Now, we have gotten this. We are good to go. The question wants us to find the velocity of A, the actual velocity of A, the magnitude and the direction. But what information do we have here? We were given VAB. So let us first write, but we know that VAB, how do we write an expression for VAB? Is VA plus minus, and we get minus, right? Minus this. So let me call this 1. I hope you are following. So we are going to express, you see, and now the question wants us to know. The question wants us to find this. We are given this and this, but we need to express them as column vectors first before we come and put them there. So expressing VAB and VB as column vectors is where we are now. Expressing velocity of A relative to B and velocity of B as column vectors. And how do we get it? VAB, the magnitude is 10, the direction is 45 from the north. So I will say 10, as usual, 10 sine 45 degrees, 10 cos 45 degrees. And what do we get from the calculator? 10 sine 45 gives us 7.0711. For decimal place, we get the same answer for this. Then VB, go to the question, go back. 20, the angle from the north is 300. So 20 sine 300 degrees, 20 cos 300 degrees. And this gives you what? Negative 17.3205. And this gives us 10. So for uniformity, you can add 10.00 and it's still 10. Right? Good. So, you see, this is our equation 1. Let me call this 2. Let me call this 3. So let us put in 2 and 3 into equation 1. And what do we get? Check it. 2 and 3 are here. This is equation 1. So VAB is equal to, what is VAB? So we get 7 is equal to, okay, VA is what we have been told to find. VA is what we have been told to find. So it's going to be VA minus our VB is equation 3. Negative 17.20510. Look at this. Is it not amazing? So we make VA the subject. What do we get? According to vectors. So we add this column vector on both sides. This whole thing, here will go to the right hand side and it will be plus, right? This whole expression will go to the right hand side and it will be plus. So what do we get? 7.0711 plus negative 17.3205 10 is equal to our VA. So what do we get? 7.0711 plus the minus of this, then 7.0711 plus 10, and this gives you VA, right? So VA becomes what? What do you get eventually? By simplification, you get negative 10.2494. Then this gives 17.0711. Good. So we are almost done. What are we left to find? This is the column form. We need the magnitude. How do we find the magnitude? Because the question wants us to find the magnitude and the direction of VA. The magnitude of this, the square root of this, sorry, I've omitted something. 24 plus, right? So let's go. By simplification, we will get the velocity, the magnitude of VA to be 19.912 to 3 decimal places. How do we get the direction? We can get the direction from the column vector. There's a column vector, so we can get the direction from this by drawing. So let me transfer it somewhere here. Don't forget, V is this. So we are done with the magnitude. It's left with the direction. 10.2494, and we have 17.0711, right? Don't forget, as I did in the previous lesson, there's positive y, negative y, positive x, negative x. So for the direction, we draw the Cartesian plane, the 2D. So the first one, x, is negative. This is negative x. Oh, sorry. The y is positive. This is positive. So you see the region where it is going to lie. Our vector is going to lie somewhere here, in this region. So I can just draw any given line. Oh, yes. So then I complete the distance. I'll put my angle. Somebody can put it here, but I don't like making it to the y. I'll make it to the x. So let me put it here, theta, or whatever you can call it. Okay. So where is my x? My x is 10.2494. Then my y is what? 17.0711. So this is vector V. Somebody can put the magnitude there, but I don't like that, because the risk in that is that if you have problem with the magnitude, it's going to affect your direction as well. So I would prefer to use the column one. All right. So opposite adjacent. This is our 90. So opposite adjacent. Tan theta, using the trigonometric ratio, 17.0711. If you don't have any idea on trigonometric ratio, you can pause the video, search for it, then you come back and continue. 10.2 494. And this gives you what? When we divide this, we are going to get 1 to 4 decimal places. We get 66. I prefer you use more decimal places so that you will not be far from the final answer. So our theta will eventually be the tan inverse of 1.666656. And this gives us 59.02 degrees. So you see, this one too, how can you state it? It's west theta north, right? So we are done. Let's continue and conclude. So how do we conclude? Go to the question. The question will guide us to conclude. Find the actual velocity of A in magnitude and direction. So I will say that the magnitude of A is 19.912 meters per second. The direction is and the direction is 59. But check the diagram. West theta, west 59.02 degrees north, right? So that is that. Or somebody, as I said previously, somebody can also say that the magnitude of A is 19.912 meters per second, and the direction, you can also take it from the north, okay, in clockwise direction. So it means that you need the whole of this angle. You need this angle and add it to this. This is our VA. So the angle from the north in clockwise direction to where the VA is. And how do you find this? This is going to give you 270. Check it. 270 plus theta. 270 plus theta. And you get 270 plus what? 59.02. And this gives you what? 329.02 degrees. So that is how we solve questions of this nature. Can go back. This was the question. We started from here. We came here. Using the steps I gave you, we came here. From here, we came here. And we have landed here. All right. On this note, I want us to end our lesson on relative velocity here. I hope you have enjoyed the video. Let me hear from you, your comments, your questions. All right. I'm giving you these trial questions. You can pause the video, write them, see if you can get the answers. This is when I solved it. This is what I got. I don't know if you get the same thing. So after getting it, let me hear from you. You get answers like this. Thank you very much and hope to see you